We learned the methods of preparation, and as I told you, the first method of preparation which I want to teach is from alkanes. The first method of preparation comes from alkanes. I told you when you are doing alkyl halides, I want you to learn to prepare alkyl halides from all classes of compounds. The first class of compounds is alkanes. These are the reactions that you have learned in class 11. When you learned alkanes, the first property of alkanes that you learned was halogenation. Okay, halogenation of alkanes. Alkanes are otherwise very, very unreactive compounds. Alkanes are actually known as paraffins. Why are they called paraffins? Because they are not reactive. They don't react. There's only one reaction of alkanes, and that is halogenation. Other one is combustion. So halogenation means substituting or putting a halogen in place of a hydrogen, right? So you see, this is methane. So it is, what type of compound is methane? It is a saturated hydrocarbon. Saturated hydrocarbon. And as a result of the reaction, what do I do? I replace one hydrogen with a halogen. So I will get a halogen here. So what did I do? I replaced the hydrogen with a halogen. So can you tell me, any one of you, can you tell me what type of reaction is this? You have learned in 11th standard 3 types of reactions, isn't it? One is addition, the other one is substitution, and the third one is elimination. What type of reaction is this? Tell me. It is a substitution reaction. Substitution reaction. So by undergoing a substitution reaction, the alkanes can be substituted, hydrogen can be substituted with a halogen, and you can prepare alkyl halides or halogen derivatives. Monohalogen derivative, dihalogen, trihalogen, and tetrahalogen derivatives can be prepared. So what is the first important thing of this type of reaction? They are substitution reactions. Now these reactions are, especially in case of chlorine, it is carried out in presence of sunlight. The sunlight, if you represent it on an arrow, you can write H nu. H nu represents sunlight on the arrow. So if it is happening in the presence of sunlight, then what happens is that the sunlight breaks chlorine into free radicals. If you remember from class 11, this is a free radical substitution reaction. So this is an important thing to understand. This method by which you prepare halogen derivatives of alkanes in presence of sunlight, this is known as a free radical substitution reaction. You can get mono, di, tri, tetra halogen derivatives, and this reaction is a continuous reaction. You can't separate or you can't remove one compound and make only one. It's a chain reaction. It continues. Okay, it continues. Okay. I'm sorry. So now you can manipulate the conditions in order to get one product or the other. Like if you want to get a high yield of methyl chloride, use excess of methane. Bromination, just like chlorination of alkanes, is done at high temperatures. You can also use high temperature to bring about this reaction. Iodination and fluorination, these two are very difficult. They are difficult. So because of these two being difficult, that means you can't substitute iodine and fluorine, because fluorine is very, very reactive. So you will not get you can't get alkyl halides. Iodination is a reversible reaction, so you don't attempt. So by this method, you either make alkyl chlorides or you make bromides. You don't make iodides and fluorides. Hariharan, do you remember the two reactions that you have learned to prepare iodoalkanes and fluoroalkanes? A fluorine.
Halogenation, ma'am.
Uh, there are two separate reactions which you would have learned, especially for preparing iodine and fluorine derivative. You remember Swartz and
Schwarz
Finkelstein?
reacts, yes, ma'am.
Yeah,
Finkelstein and
Swartz.
Schwarz, ma'am.
Swartz. So we'll do those a little later. Now, there are more things which we need to learn here. Okay. So supposing I have an alkane like this, there are C5 and H12. This is an alkane. Now, in this alkane, there are, if I say C5H12, there can be different isomers of C5H12. I can write 3 isomers of pentane. Okay. N-pentane, isopentane, neopentane, or 2-chlorobutane, 2,2-dichloropropane, and whatever. Now I do chlorination. Okay. Now when I do chlorination of this one, first one, so I do chlorination here and chlorination here, and I only one hydrogen, the first hydrogen has to be substituted. Now you see there are two types of chlorine carbon atoms here. This is primary, this is secondary. So I can get two monohalogen derivatives. What are the two? 1, 2, 3, 4, 5. One Cl can come here. Cl can come here. The other one is, let me write all the possibilities in this case. Okay. Now you see, so there are two types of carbon atoms, so I can get two types of halogen derivatives. Now in this case, how many types of carbon atoms are there? 1, 2, and 3 types of carbon atoms. So I can put a halogen either here, or I can put it here, or I can put it here. All right. And in this case, there are only two types, but hydrogen can be substituted only on this one, Cl. Whether I put it on any one of them, it's the same thing. So I can get only one monohalogen derivative. I hope you understood what I'm saying. See, what I'm trying to say is that the monohalogen derivatives depend, means when one halogen only has to be substituted, the number of monohalogen derivatives depend on the number of hydrogen atoms, types of hydrogen atoms which are present. So here this first one, it has two types of hydrogen atoms, primary hydrogen, secondary hydrogen. So I can get a primary alkyl halide and a secondary alkyl halide. In this case, there are three types, 1, 2, and 3. So I can get 1, 2, and 3 types of alkyl halides. And in this case, there are two types, but hydrogen is only one type. All of them are primary. This is primary, this is primary, this is primary, this is. So I will get only one type of alkyl halide. So you will get only one monohalogen derivative. Now the question here could be, the question when it is asked in the exam is, there is an alkane C5H12 and it forms only one type of monohalogen derivative. It forms only one type of monohalogen derivative. What is the structure of the alkane? How will you know? Only one type of monohalogen derivative is where? In this one. So which is my alkane? My alkane is neopentane or 2,2-dimethyl propane. Did you understand what I'm saying, all of you?
I have a doubt.
Tell me.
You said for halogenation, equal number of hydrogen atoms will be replaced by equal number of chlorine or bromine atoms, right? For halogen. But here in this process, we are adding two Cl2, which is 2 chlorine atoms. Then how are we getting just 1 chlorine atom in the product?
I didn't get your question. Only one chlorine. So where is the other chlorine going? Is that the question?
Yes, ma'am. Where is the other chlorine atom?
Where is the other chlorine? The other chlorine is, see, supposing you have CH3Cl. Let me start from methane. So supposing you have CH4, and you are reacting it with chlorine, what is happening actually? The one chlorine is replacing the hydrogen. The other chlorine is reacting with, so you get HCl. The second chlorine is going to the HCl.
Yes.
Supposing I take CH3, CH2, 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 CH3, and I replace it with chlorine, the first product, I'm talking of that first product where only one hydrogen is replaced, only one. So monohalogen derivative. So you will get what? CH3, CH2, 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 Cl plus HCl. That is one possible product.
So the hydrogen which gets displaced, it will react with the free chlorine atom and gets converted into HCl.
HCl, yes. What I am trying to say is that in this case, I can get two possible products. The one product will be this one, right? And the second product could be CH3C, this one also, right? This is also possible. So in organic chemistry, the interesting thing is there are, you can't write stoichiometric reactions like you write in inorganic chemistry. Here, multiple products can be formed. So some chlorine molecule would be doing this. Another chlorine molecule would be doing this plus HCl. So many side reactions will be happening. All right. So you could get 2 chloropentane and you could also get 1 chloropentane. Now, which will be the major product? The major product here would be 2 chloropentane. This will be the major product. Why this will be the major product? Because when substitution happens, then tertiary hydrogen is substituted fastest and then primary, secondary, and the least or the slowest is primary. All hydrogens will be eventually substituted, but which one will be substituted fastest? The tertiary. Tertiary one will be substituted fastest and then primary and then second. Okay, so if I have only first product, if I am able to measure the yield of the first product only, then you will realize you will get more of secondary, this one, 2 chloropentane, and the percentage of 1 chloropentane will be less. Okay, but you know that this is a chain reaction. Reaction will not stop here. Then all the hydrogens will be substituted one by one, one by one, one by one. So that is how. But when the question is asked, then the question is like this. Among the isomeric alkanes of C5H12, identify the one that on photochemical chlorination yields. So this is the next homework, and I will stop at this.